Awesome. And part of that, he was a solution architect at Rackspace, working on big data and DevOps and PaaS technologies. So, and the topic today is going to demystify sharding for us. So with that, give a big round of applause for Dawoud.
Am I on? Okay. Hi, everybody. I think this is one of those interesting subjects that everyone seems to be interested in, but also afraid to tackle, honestly, and for obvious reasons. And I just want to take a quick survey. Who's thinking about sharding around here? Okay, not a lot of you. Okay, all right, cool. All right, well, let's talk about sharding basically. I want to talk about the basics, some of the things that you actually already know, and then we're going to dive into what sharding is all about, what is the architecture of the cluster, and then take it from there. So we're going to talk about the intuition, the behind sharding, the architecture, and then what is really most important about sharding. And then I'm going to end with showing you an example of when things are not really done right. And it does have its own ramifications as well. Now, if you start with MongoDB, the way we do things is basically, as you know, we deploy a 3-node replica set. And over time, basically, what happens is we do that for the purpose of high availability, redundancy, and so forth. Now, over time, which is applicable to MongoDB and otherwise, is that performance is you're gonna have more demand because you have more users hitting the application or the database. You have more data that's coming into the environment, and so you need to deal with all of these issues. And there are different ways of dealing with that. One of them is if you look at every cluster that you build, whether it is in Atlas or on-premise, you will always have a finite amount of resources, CPU, RAM, or what have you. Now, the idea is to optimize as much as possible of these resources before you actually think about other avenues. Let's say, for example, scaling up. Okay, this is one of those obvious areas where our customers we see it all of the time, is that when you hit those kind of performance problems, data explosion, you can see some of those problems that Asya was talking about is what do we need to do here? The first thing that comes usually to mind is scale up. Because what you're really doing is you're throwing resources at the problem or you're throwing money at the problem. So before you actually do that, which is an extension to what Asya has said, is look at the root causes of how things are happening. But there are limitations that you really have to take things to the next level. And this is where basically when you have a cluster that cannot handle the amount of resources that asked of it, then you need to think about the sharding algorithm or basically sharding approach. What sharding does basically is we're taking the same data that's sitting in one cluster today on one disk, and we're subdividing it or distributing it across multiple replica sets. So each one of those replica sets becomes a shard. And if you look at the shard architecture itself, each one of them is like a mini cluster by itself. So, each shard will have a 3-node replica set. And again, we keep in mind that every shard, because it's going to have a primary and 2 secondaries, we still have to maintain the high availability concept of that cluster, just in case of failures and so forth. And again, when you are approaching sharding, there are certain things that you need to keep in mind, and what are the benefits that you're trying to get out of it. One of them is basically to increase the storage capacity. I can actually give you an example of a customer that we're working with as we speak. They have a 3-node replica set, about 38 terabytes worth of data in a 3-node replica set. And guess what? The kind of limitations that they're hitting, in Atlas it would have been a long time ago, but they're actually even pushing the limits of the disk or EBS volume that's available on AWS. So what they want to do basically is we're talking to them about how can we actually solve the problem or the disk capacity. And I'm going to talk about the approaches of how you do that actually before you get into this. Now, when you are really scaling out also with sharding, you are actually getting more resources. When we're talking about more resources, because each shard itself is a replica set in its own. So technically, if you have a 3-node replica set that runs 64 gigabytes, for example, and you subdivide it in 2, you could actually, if you maintain the same size, sometimes you really don't have to, and most of the cases you don't, then you're actually doubling your memory, doubling your disk space, and so forth, and you're getting more throughput. Because what happens now, your disk space, you have 2 disks, each one for, if you have 2 shards, for example, or as many shards, the disk capacity from an IOPS perspective has now been multiplied by the number of shards. So that gives you actually that kind of thing. So for example, in a lot of IoT applications specifically, when you have a lot of data coming from sensors, sharding will definitely make a lot of sense because you are dealing with a lot of data and you're trying to keep up with the writes as well and sometimes the reads as well. Okay. The other thing is basically when we're talking about sharding, there are different scenarios for sharding, of course. One of them is basically running out of disk, or your data is getting beyond a certain point where we start recommending sharding itself. So there are certain scenarios, even if your disk size, if your data is within certain limits, like 2 or 3 terabytes, but you may have a GDPR requirements where you have other customers sitting on the other side of the pond, then even if you have 200 gigs of data or 100 gigs of data, to maintain that kind of data governance or data requirements, you actually have to push that thing to a shard by itself. Make it much closer to the customer from a performance perspective. You meet all of the data locality requirements and what have you. Okay? So these are some of the reasons that you do that. And again, performance is one of them. You could have customers all over the world as well. This is where you can build a global cluster with sharding all over the place, and you can actually introduce redundancy into this as you move forward. Now let's talk about the architecture of a sharded cluster, which is something I just alluded to. So when we say, when you shard, each cluster becomes a replica set on its own. What that means basically is going to have its own memory, it's going to have its own disk space, and it's going to have its own CPU. So basically, you are really distributing the data across multiple shards to work with. So the data set now is divided. Now what we're doing is we really have more of a distributed computing environment, if you will. Okay? Now, the way we distribute the data across those shards is a very key thing. And this is exactly where a lot of the problems that our customers are really reluctant to approach sharding and so forth. It's not really, it's not something scary. Honestly, it just has to be done right. So the first thing that you need to do is to make sure that you pick the right shard key. And why is the shard key important? Because the shard key will always make sure that the data is distributed evenly across all of the shards. And why is that important? Because now you're distributing the processing across, you're subdividing the processing across all of the, as many shards as you have, which is also important to make sure that you also are utilizing the existing resources. Because if you do not choose the key properly, you may wind up with scenarios where one of the 2 shards are just sitting idle and the other ones are just doing all of the work. So that's why picking a shard key is really key to sharding. Now, I'm wondering if someone has approached sharding and had hit the scenario of a bad shard key. Any show of hands? If you're reluctant to say anything, that's fine. Oh, someone has, okay. All right. Yeah, look, this is a very critical exercise. Most likely, you may not get it right from the beginning. That does not mean that you should really back down from it. It's just an exercise of understanding the access patterns, how the data should be distributed, and then you'll get it. Also, in the older version, and I know where the reluctance is coming from, in older version with MongoDB, if you got it wrong, which means that you have to pull all of the data out, recreate your shard key, and then bring it back in. If you have terabytes, it's going to take a lot of time. Now, with the new versions of MongoDB, basically the 5.0 and then 6 and so forth, you can actually shard on the fly. Yes, it would require resources, but it's not going to require the kind of headache that is going to stop your production and so forth or slow it down. Okay? Okay. So we said the shard key is very important. Now, one of the things that we do in the background, what is going to happen is that the data is always going to be hitting at the very specific shard based on what the query router basically actually do. And what we do all over the time is we keep track of the data sizes, and we try to auto-balance the sizes in all of the shards to make sure that the load is evenly distributing as well. okay? And I think with versions 5.0 and 6.0, we're coming with more optimized technique to make sure that the process is not really dragging a lot of resources or dragging the cluster down, okay? Okay, now, another form of sharding, we talked about sharding as a concept. Now, there are different ways of doing sharding. The example that you looked at a minute ago was really more of a range sharding, but there is a concept of a hash sharding. For example, if you're having a problem of really balancing the data across all of them, hash sharding will actually help you in a sense that it will always guarantee that all of the shards have the same kind of amount of data. Okay, now is that a good solution? It depends. It depends on the use case. For example, if you are running queries that actually do range, we will not guarantee that the data range that you're looking for will be sitting on one shard, because this is hashed algorithm, okay? So if you have a use case specifically that, for example, we're going to see one of them, is that if that use case specifically target that customer, and you know the customer data, for example, will be sitting, or the data will be sitting in that shard, it's really a good thing. So if your algorithm is always, or the application is hitting one customer or one subset of the data that you know is going to be very close to living together, then that is really an elegant solution, okay? Because it guarantees that you have a distribution in there. Now, range sharding is based on the fact that when we look at the data, we actually subdivide it based on the shard key, of course, but we actually split it across across different shards based on the ranges of the data. For example, let's say you have a customer ID from 1 to 300. First 100 will be in shard 1, second 100 will be in shard 2, and so forth and so on. Now, over time, things will grow, things will change, data will be deleted, introduced, and so forth. Then we will do the balancing in the background to make sure that they're always even as well. But you want also to make sure that you do the exercise of picking the shard key, the range shard key, based on what you really want to do. Like, for example, I just gave an example. If you're doing a lot of range queries, this is a perfect set, because you know that the data is going to be very close to each other as much as you can, okay? Okay, zone sharding. This is one of the exercises, I think, when we talked about some of the use cases of sharding is, let's say, for example, data governance requirements or data locality requirements, okay? So honestly, there are two approaches to this. One is to do sharding, meaning that few of the shards will be the US, some of the shards will be some other place, let's say, for example, in Europe and so forth. It is really has, A, it meets the requirements of data locality, B, the performance requirements today. Our users do not have to come in across the pond to do a query and so forth. So this is for performance kind of thing. And actually with zone sharding, you can actually have multiple shards under the same zone. So if you're running out of data in that locality, it does work very well as well for you. Okay, so this is one of the scenarios. And again, usually sharding comes in the context of data size or resource sizes and so forth. This is one of the things that specifically like GDPR or data locality breaks that kind of thought process, because you really have to have that thing as well. The other scenario, which is I need to mention, is if there is really no requirement for that data to be merged together. Let's say, for example, someone is running a query across the entire thing. If that scenario does not exist, sometimes it's much more easier just to create a cluster in that specific region instead of actually sharding the cluster. So it depends on the use case. There is nothing set of stone that if my data size is going beyond certain limit and I need to start sharding. You can actually break the data if it is that in that kind of domain, and you can actually do it. Your requirements do not ask you, or you do not have any obligation to actually merge the data together. Okay? All right. So this is an example of sharding. For example, we have 20 terabytes, 7 terabyte storage size. This is due to compression. This is similar to one of the customers that I have. So if we shard this data, which is the 20 terabytes across multiple shards, we're going to come up with 7 shards, okay? Now, what does that mean is that now our data, regardless of its size, we're going to take it and subdivide it across all of them, which is 1 terabyte each. And whether, in this case specifically, it could be either range or horizontal, sorry. It doesn't matter. But the idea here is now you're getting much more horizontal scaling. you get more disk space available for you to grow in every shard, and you get more resources. So technically, if you think about it, okay, you're getting about 1.4 terabytes of the working set data in memory because every shard will has 200 gigs of RAM in this example. So every shard is going to have its own local resources, CPUs, and so forth. Now, one of the things I always want to talk about, maybe it could be very close to this subject. If you think that you have performance problems based on a data size to a certain degree, and you start sharding, yes, you may solve the problem, but you're not really addressing the main problem of why did we get there. What I mean by that, if you have bad queries or bad schema or whatever, that creates a lot of contention in the database or what have you, or bad indices. If you split the data, there wouldn't be a lot of queuing on IOPS and all that stuff. You're going to see that performance benefit. However, you have not dealt with the underlying problem. So what I say, again, coming back to Asia's session, is to make sure you tackle the performance problems before you actually hit anything. Does that make sense? Okay. Now, what is the life cycle of a query? So now your data is split across multiple shards. How does MongoDB know where the data is living? Okay? Now, if you're managing your clusters on house, for example, on premise, you know that when you're setting up sharding, you would require actually more processes. It's not just a 3-node replica set. You will not require now the configuration servers, which is part of the sharding cluster, and the MongoOS processes. The configuration servers basically keep track of all of the changes that happen and keep track of where the data is sitting on disk. So for example, you're seeing a scenario of a range sharding, and where the data is subdivided into 3 sets across the multiple shards. So if we do a query here, okay, we're going to query against the MongoOS. Now, one of the things in sharding, you find it in our documentation, do not connect directly to the shard, to any shard directly, and try to do anything in there. That's not a good behavior, by the way, because you're bypassing the process, which is a key process. There will be scenarios where you have to do that, but under the provision of technical support, because there may be scenarios we have to deal with. But beyond that, do not do this. Everything needs to come in through the MongoOS process, because why? The MongoOS is really your router. It knows where the data is, and we're keeping the data all of the time in the configuration replica set. So what the MongoOS do, it's Mango. It's basically, I'm not really that hungry, but I like the mango as well. Okay. So what happens is basically the query router, every time you bring a query to it, when you connect to it, it's going to look at the shape of the query, and it's going to make a decision. Now, where does the data exist? Based on the actual routing table that exists in the configuration server, okay? Now, from there, we can decide that this data, for example, could be sitting on shard B. We're going to target shard B, okay? Now, again, if your query is based on a shard key, this is because, remember, the shard key will be designed based on your access methods, and this is very key. Get it right from the beginning. We're not just talking about just putting the size here, there, and there. No, that's not. We're going to look at the access methods to make sure we have an even distribution. So it's a function of the size of the data and also a function of how you're querying the data as well, that distribute the data to make sure that the data is actually, or the load is evenly distributed. Now, for the sake of argument, what if I provided a query that does not have a shard key, or at least one of the components of the shard keys? What is going to happen here? What's that? It's not going to take forever. What's going to happen? We're going to hit every shard. Now, we're going to make everything busy at the same time. So what exactly have we done? So the idea here is to make sure that your access or shard key is designed based on that. Because in this kind of a scenario, that kind of a query, we call it scatter-gather. As we're going to send it, broadcast it to all of the shards. We don't know exactly where the data is sitting because we don't have enough information about that. The MongoOS does not know. So it's going to send it to all of the shards, and then all of the shards is going to respond, whether it has it or not. Again, it depends on what happens afterwards, okay? But most of the time, if you do not provide the shard key, this is what's going to happen, okay? So if shard key B satisfies the query, we're all good. finds a list of customers. For example, if you want to, here is a scenario where you want to find a list of customers that's as sitting in different things. If we, for example, for the sake of argument or an example, we give a customer ID of 300 arranged to 400. In this kind of a scenario, the data is sitting where? In 2 shards. Now, how do we know it's sitting in 2 shards? Because the MongoDB process has that kind of mapping, okay? And then it's going to push it to both shard A and shard B to get the data. So once the data goes there, MongoDB process is going to take it, merge it together, and then hand it back again to you, to your application, okay? All right, let me make sure. Okay, and this is exactly how I think I'm going ahead of myself. I'm trying to keep on time as well. I want to show you a very important example of what's going on. Again, every time we add data to the cluster, that routing table or the config server data will be always updated, okay? And MongoDB will keep refreshing that data from the config server as it goes along, okay? To keep track of where the data is actually sitting in the cluster, okay? All right. Okay, if we want to insert 500 customers, this is one of the scenarios. This is one of those, if you have a certain scenario where the date is part of your shard key, it's going to be increasing over time, and guess what? It's going to start hitting the last shard. And that could happen as well. So what MongoDB tries to do, we don't want to design for that. But if you have those scenarios, for example, where you're just adding the customers and happen to be here, what MongoDB actually will do, it will try to rebalance the data, move it between shards to make sure they're evenly distributed. Does that make sense? Okay. All right. Okay, so what is a shard key? Well, I guess it's the first one of more fields, of course. I mean, you're dealing with a document, data in the database, it has to be a field, okay? And based on that field, basically, MongoDB decides the ranges of values based of how you've actually created that shard key, okay? And then one of the things you need to do is to, again, coming back to the point that I keep repeating, you need to make sure that it is based on your access patterns and that's why you want to choose the correct fields that you use most often to access the data, okay? So guidelines, all documents have field. Of course, I mean, all of the documents will have field. Unless you have a document that's all text, that's a completely different conversation. But we've seen that, by the way. So that's not going to be a shard key. High cardinality to make sure that you have an even distribution as much as possible. Again, depends on the number of shards and so forth. So for example, a yes/no kind of scenario, that's not really a good shard key. Okay? A state, maybe, but you need to be watching for this, and it's logical for your query patterns. That third one is very important, okay? Okay. So what is a great shard key? This is an example of a hospital. I mean, I want to rush through the example because I want to show you some kind of an example of a sharding algorithm. Here we have a patient document. If each patient will have an ID. Now, specifically because, again, it depends on the scenario. In the medical field, when you're dealing with one patient who's checked in the doctor's office, in a hospital. So in this kind of a scenario, before I move forward, what do you think a good shard key will be? I don't see everyone, but anyone can shout, by the way. What is a good shard key here? What's that? Patient ID, exactly. What kind of a sharding algorithm or basically mechanism we should be using here? So we talked about range sharding, hash sharding, and zone sharding. Hash? Okay, well, I think you guys, okay, well, that means it's either I'm doing a good job or what is a great guess. Okay. All right, so in this kind of a scenario, we have data sitting in different things. Okay. So when you hash, basically, this is how the hash function would look like. When we insert the data, as I said, the data is going to be inserted randomly on those shards to make sure we have an even distribution. So this is something, honestly, this is the easiest kind of sharding that you could do. It doesn't require a lot of work, but again, keep in mind the use case. Is it really, are you doing a lot of ranges or not? That is very important, okay? Okay, live sharding. So these are some of the features that are coming up, and I know I mentioned earlier that there is a reluctance of using sharding because you don't want to get it wrong. What we're doing now is we're making it much more easier for you to have those kind of mistakes. That doesn't mean that you don't want to get it right up front. So if you have 200 gigs or 100 gigs worth of data, or I don't think this is even a good scenario for sharding, but if it is 1 to 2 terabytes, this is something you could do. It can rebalance within, maybe you could do it within 2 days or 3 days. But if you have tens of terabytes, I would definitely pay attention to what I'm doing and make sure you test it. And that is key, okay? Any combination, now, this is the new feature, so you can actually change your methodology between compound to range, range to range, or range to range, which means you're changing just the range itself, the range fields themselves, or range to hash, okay? You need to test exactly, and then this is a peace of mind. These are just talking about the new features as well. Let me get into, actually, before we do that, okay, it's a cost-effective solution, by the way. And again, one of the things you want to pay attention to is sharding does not mean you have to replicate an existing cluster. What does that mean? Let's say, for example, you're running on an Atlas, on an M40. If you create another shard, does not mean you have, based on the data requirements, if you're running out of data, that does not mean that the second shard has to be an M40. Maybe the whole cluster can be brought down to M30. Because now you have more RAM, or basically equal amount of RAM, but your problem is disk. But if there are other factors that do not really are not problem from a performance perspective, you may actually, you can degrade actually the cluster. Does that make sense? All right. Okay. All right, so here's a scenario. This is the scenario that I wanted to talk about of how important of getting the shard key right. Can you, if you look at this one, this is a scenario of a customer. Okay, this is a managed environment. This is a cloud manager view, or maybe the ops manager view, which is a similar thing. You can see, look at the amount of RAM that they have, 768 gigabytes. That's a lot, okay? And they have 2 shards. So this is a very huge environment. By the way, by Atlas standards, this is the limits. You cannot go beyond that. It's an M700. 96 cores for every node. That's a lot, okay? So far, so good? Now, let's look at this scenario. They are sharding. Can you see what's going on here? This is the data size on every shard. What does that tell you? What's that? Exactly. So what we're doing is, this is completely unbalanced. 10% of the data is sitting on one shard, 90% is sitting on this shard, on the second one. The customer is complaining about performance problems. Is that expected? And they know there is a problem here. The thing is, their business is growing. They do not have time to stop and actually deal with this issue. And guess what? They're expecting, for example, 10 times the size of data that they have today. That's going to be a very huge problem. And look at the data growth over time. So one of the shards, which is shard 1, there is no data growth, almost. The other one is actually, everything is actually hitting that shard. Let's talk about another thing. Here is what are we talking about? This is the shard, the app log. You can see that the data that's coming, hitting the log, all of the activity is happening where? On shard 2. The other one is doing what? Remember, the other one has what? 768 gig of RAM, huge disk space, sitting down doing nothing. And these are 2 nodes. And actually 4 nodes because there are, 3 nodes because there is a third node. There was another problem in that design, but I didn't want to point it out. But I'm telling you, basically, this is where the activity. Do you think we've achieved what we're looking for if we're trying to distribute the load across multiple shards? No. This is really a waste of money and resources, honestly, if you think about it. Now let's look at basically another one, query. Look at the queries. The queries is really hitting the shard 2. Shard 1, yes. Okay? Because It's a natural behavior because all of the load is going to the other shard. And look at the amount of queries that's hitting there. Talking about 12,000 a second. Okay? This is what? Cursor's open. Again, shard 1 is doing nothing, almost. Look at this. So which means that even though we have 6 nodes for 2 shards, one of the nodes, which is the primary, is doing all of this work. Of course, the replica set is doing also part of that as well because it's going to replicate everything. But look at this kind of example. Is that an example you want? And this is really was based on a poor choice of, and the customer acknowledged that. They know that this is a problem and they have to solve. Okay? Okay, I am hitting time. So this is documents. This is all showing that the data is getting there. Now, oh, okay. I'm out of time. All right. Can I take 1 minute? Okay. I want to take 1 minute actually to talk about something important. When we're talking about sharding, specifically when we're talking with customer, the customer I just alluded to or mentioned earlier, they have about 40 terabytes worth of data. When you're considering sharding is going to solve a lot of problems, but the question always for you to ask, do I really need all of this data to be sitting in this cluster? This is a very key question because we're going to take the data and split it across. But if you have historical data, what is your retention policy? We can actually archive this data, throw it in an S3 bucket, and you can actually query it the same way you do today. You know, it's going to just be sitting on an S3 bucket. Can you do that? Of course you can. But you really need all of this data in there because that data, if it is stale data, is going to be sitting in your cluster. It's going to require a lot of space for indices. It's going to require a lot of space for RAM and performance implications, so forth. And above that, money. So you need to think about that kind of thing. Before you approach sharding, ask those questions. There are a lot of good cases where you definitely need sharding. I'm not saying try to avoid it. No, just approach it the right way. Okay? I'm done with my minute. Thank you.
Thank you. I've known Dawoud a really long time, and the last minute is always the best minute. Thank you very much.
Thank you.
We don't have time for questions, but you're going to be around? You're going to be around?
Yes, I
during
will be
happy hour?
around for the, next 20
Okay.
minutes. Yes.
Thank you guys so much. We've got 5 minutes for the next talk, our last talk of the day, and be sure to stick around for happy hour and light bites afterwards. Thank you, Dawoud.